Class 12th, Subject Physics, 6th chapter, Superposition of Waves. Superposition of waves. From the chapter, let us see the vibrations of air column in a pipe open at both ends. The vibrations of air column in a pipe open at both ends. So if the pipe is open at both ends, then when the air column is created inside it, then the boundary condition which will be hold good, that is, there will be always formation of antinodes at the both open ends of that pipe. So at the open end of that pipe there will be always formation of antinodes. So when the air column is created inside this pipe, at that time the air inside the pipe is slightly denser as compared with the air outside the pipe. That means inside the pipe it will act as a denser medium and outside the pipe it will act as rarer medium. When the progressive waves are passed through one end of this pipe, at that time these progressive waves will travel first through denser medium and then it will enter into the rarer medium. So from the boundary of this rarer medium there will be partial reflection of these progressive waves, and therefore when there is superposition between the incident wave and the partially reflected wave, the stationary waves will be produced inside the pipe, which will be consisting of antinodes and the nodes, and therefore this pipe will now vibrate by different modes of vibration. Let us consider first three modes of vibration of the air column. So let us consider the first one, that is first mode of vibration of the air column. For that purpose, let us consider a pipe which is open at both ends having its length equal to small l. Then when that air column is vibrating in the first mode, that is simplest mode of vibration, at that time there will be formation of two antinodes and one node. So in the first mode of vibration of air column in a pipe open at both ends, there will be formation of two antinodes along with one node, and hence if lambda represents the wavelength of this wave, then length of the air column capital L will be equal to lambda by 2. L is equal to lambda by 2, and therefore we can say that as length of the air column L equal to lambda by 2, or lambda will be equal to 2L. Therefore lambda will be equal to 2 into L plus 2E. L plus 2E, because 2E will be here because there will be end correction at both these ends, and therefore lambda is equal to 2 into L plus 2E. Now if N represents the frequency of vibration of the air column for the first mode, if N is the frequency of vibration of the air column for the first mode, then we can write as V equal to N lambda, therefore N will be equal to phi by lambda. N is equal to phi by lambda, and therefore, but lambda is nothing but 2L, therefore N is equal to phi by 2L, that will be equal to phi upon 2 into L plus 2E. So N is equal to phi by 2L. This will be the lowest frequency of vibration of that air column, which is called as the fundamental frequency or first harmonic. Fundamental frequency or first harmonic. Now let us consider second mode of vibration of the air column. So when this air column is vibrating in the second mode, at that time there will be formation of three antinodes along with two nodes. That means in the second mode of vibration of air column in a pipe open at both ends, three antinodes and two nodes will be formed. Again, if lambda 1 is wavelength of the wave, then length of the air column L will be equal to lambda 1. L will be equal to lambda 1, and therefore as length of the air column L is equal to lambda 1, length of the air column L is equal to lambda 1. Therefore, lambda 1 will be equal to L, that is L plus 2E. L plus 2E. Now, if N1 is the frequency of vibration of the air column, if N1 is the frequency of vibration of the air column for the second mode of vibration, then N1 will be equal to phi by lambda 1. N1 is equal to phi by lambda 1, that will be equal to phi upon L plus 2E. Phi upon L plus 2E, and therefore we can write N1 is equal to 2 phi upon 2 into L plus 2E, because this relation is multiplied and divided by 2. Therefore, N1 is equal to 2 phi upon 2 into L plus 2E. Therefore, we can write as this phi upon 2 into L plus 2E is N. Therefore, N1 is equal to 2N. This is the next higher frequency, that is N1 is equal to 2N, which is called as the second harmonic or first overtone. Second harmonic or first overtone. Now let us consider third mode. In the third mode of vibration of air column in a pipe open at both ends, there will be formation of 4 antinodes along with 3 nodes. So in the third mode of vibration of air column in a pipe open at both ends, 4 antinodes and 3 nodes will be formed. If lambda 2 represents the wavelength of this wave, then length of the air column L will be equal to 3 lambda 2 upon 2. 3 lambda 2 upon 2. And therefore we can write as length of the air column L is equal to 3 lambda 2 upon 2. Therefore, lambda 2 will be equal to 2L by 3. Lambda 2 is equal to 2L by 3, and therefore it will be written as lambda 2 equal to 2 into L plus 2E upon 3. Lambda 2 equal to 2 into L plus 2E upon 3. If N2 is the frequency of vibration of the air column in the third mode of vibration, if N2 represents frequency of vibration for this third mode, then N2 will be equal to phi upon lambda 2. N2 is equal to phi by lambda 2, that will be equal to 3 phi by 2L. 3 phi by 2L. It will be also written as N2 is equal to 3 into phi upon 2 into L plus 2E. But phi upon 2 into L plus 2E is nothing but N, and therefore we will get N2 is equal to 3N as the next higher frequency, which is called as the third harmonic or second overtone. Third harmonic or second overtone. So in this way, the vibrations of air column in a pipe open at both ends will contain frequency N, 2N, 3N and so on. That means the vibrations of air column in a pipe open at both ends will contain all harmonics. That is, all harmonics are present in the vibrations of air column in a pipe open at both ends. And therefore, in general, for pth overtone, we can write Np is equal to P plus 1 into N. Np is equal to P plus 1 into N, where P is having its values 0, 1, 2, 3 and so on. So this will be regarding the vibrations of air column in a pipe open at both ends. Now let us see the next point, that is practical determination of end correction. So end correction can be practically determined in case of a pipe closed at one end as well as open at both ends. For that purpose, we will have to consider the relation phi is equal to NL, that is the fundamental frequency in case of a pipe closed at one end as well as open at both ends, that we will have to consider. In case of pipe closed at one end, if we consider the first case, that is for a pipe closed at one end, the fundamental frequency will be given as N is equal to phi by 4L. N is equal to phi by 4L, and therefore we can write phi is equal to 4 N1 L1 equal to 4 N2 L2, because that phi is equal to 4nl. That will be constant as velocity is constant, and therefore we can write 4n1l1 must be equal to 4n2l2 as phi is constant. 4 will get cancelled and we will get n1l1 equal to n2l2. n1l1 equal to n2l2. Now putting the values of l1 and l2 in terms of end correction, we can write n1 into l1 plus e equal to n2 into l2 plus e. As this pipe is closed at one end, therefore end correction will be only e, and therefore multiplying by n1 we will get n1 l1 plus n1 e is equal to n2 l2 plus n2 e. Then further we can write n1e as it is, then taken this n2e towards left side, we will get n1e minus n2e equal to n2l2 minus n1l1. So either we can write n1e minus n2e or n2e minus n1e. So we have written here n1e minus n2e. Taking common e, we will get e into n1 minus n2 equal to n2l2 minus n1l1, n2l2 minus n1l1, and therefore we can write e equal to n2l2 minus n1l1 upon n1 minus n2, n2l2 minus n1l1 upon n1 minus n2, or also we can write e is equal to n1l1 minus n2l2 upon n2 minus n1. So this will represent, these two equations will give us the end correction in case of a pipe closed at one end. And now let us see the second case for a pipe open at both ends. For a pipe open at both ends. Now if the pipe is open, then end correction is 2e. If that pipe is open at both ends, then end correction is 2e. Again, the fundamental frequency is given as n is equal to phi by 2l. n is equal to phi by 2l, and therefore phi will be equal to 2n1l1 equal to 2n2l2 as velocity is constant. Again, cancelling these two, we will get n1 l1 equal to n2 l2, n1 l1 equal to n2 l2. Then putting the values of end correction, we will get n1 into l1 plus 2e equal to n2 into l2 plus 2e. Therefore multiplying by n1 and n2, we will get n1 l1 plus 2n1e equal to n2 l2 plus 2n2e. Therefore 2n1e minus 2n2e will be equal to n2l2 minus n1l1. Therefore taking 2e common, we will get 2e into n1 minus n2 equal to n2l2 minus n1l1. Then e will be equal to n2l2 minus n1l1 upon 2 into n1 minus n2. n2l2 minus n1l1 upon 2 into n1 minus n2, or also we will get another formula for e, that is n1l1 minus n2l2 upon 2 into n2 minus n1. n1l1 minus n2l2 upon 2 into n2 minus n1. By using these two formulae, we can calculate the end correction for a pipe open at both ends. So this will be regarding the practical determination of end correction.